So a normal distribution has a bell shape and it's symmetric. Now there's many distributions that have bell symmetric shapes. One important one, another condition that we need to meet for it to be normal is the idea of the empirical rule. And with the empirical rule, we're looking within standard deviations for finding 68% of the data, or 95% of the data, or 99.7%. And these percentages are when we look within one standard deviation, within two standard deviations, or within three standard deviations. So if we have a symmetric bell shape, and when we look at the different sets of standard deviations, if we find our data meets those percentages, then it's probably a normal distribution. There's no guarantee. Graphically, thinking about that, this would be the center of the distribution. And here's my best symmetric bell coming from each side. So the mean represents the center of the distribution, which would be no standard deviations. I haven't moved left or right. One standard deviation for a normal distribution would be about right here. So that would be x bar plus 1 standard deviation. And then same distance jump about here, the x bar plus 2 standard deviations. And around here would be x bar plus 3 standard deviations. You can go to the other side and do the same thing. 1, 2, 3. So this would be x bar minus 1 standard deviation, x bar minus 2 standard deviations, minus 3 standard deviations. So just counting by standard deviations, this would be -1, -2, -3. And again, the empirical rule here, if we look within one standard deviation on each side, then the amount of data I expect to find in between these two values should be about 68%. And if I spread out and look within two standard deviations, so considering all the data that fits a histogram within two standard deviations like that right there, I would expect to find about 95% of the data. And then if we look again and count up how much of the data is within 3 standard deviations, so all the way from whatever this number is to that one, then we should expect to find about 99.7% of the data in that region of the graph. So here to here. So this picture is a smoothed out histogram. So that's one way to define a normal distribution. And the shape, again, they all have bell shapes, but the important thing about a normal distribution is it's always going to be centered on the mean. So not only is it a bell shape and it fits the empirical rule, but it's defined by the mean, because that marks the center, and the standard deviation, which marks the spread from the center. I just want to show a graphic of some different means and spreads, but they're all normal distributions. And I'm going to use an app called GeoGebra for that. I'm just going to tell GeoGebra the graph normal for me. And I'm going to say let the mean be 0, so 0 will be the center. Let the spread be 1. Use x for my variable. And then the false will tell it to draw the regular curve. And I'm just going to zoom in on this a little bit. So it looks relatively flat. And again, I could zoom in and change the scales and it could look very different. So for example, if I graphed this in stat key would display it different by having a stretched out y-axis. So in stat key, the graph might look more like that right there. But all I'm doing is just stretching out vertically the image. It's the same graph it was before, just with a different scale. Let's go back for a minute. That's close to the way it was originally. And I'm going to graph a different one here. I'm going to leave the same center, 0, but this time I'm going to make the spread 1/2 instead of 1 whole. And then notice that since it's not as spread out, it has to be taller to compensate for that. So one more just for fun, normal, centered at 0 with a spread of maybe 1/4. And again, it's centered at 0, but this one looks much taller because I gave it a narrower standard deviation, but they're all normal distributions. If we look within 1 standard deviation on each side of this, we'll find that within a standard deviation on any of these, the first had a standard deviation of 1. So within 1 standard deviation from here to here, I'll find 68% of the data. This one, within 1 standard deviation, which was 1/2 on each side, I'd find 68% of the data. That's going to be consistent, a normal distribution all the time, regardless of how spread out or condensed it is. And normal distributions are important for making predictions in data, regardless of whether the original population was normally distributed or not. And that's a topic we don't have time to get into right now. We look at the stat key version. Stat key's normal distribution is always put in this particular frame. So regardless of what you say the mean and standard deviation are, originally it was 0, 1. If I make it 0, 0.5, it's still going to look the same, but the scale will change on the bottom and the side every time I change the mean and the standard deviation. They're just rescaling the graph to always fit in this window. And that can be a little bit deceptive, but the shape doesn't matter. What matters is how we use it. And we use a normal distribution for making predictions about percentiles in data analysis, which we'll look at next.